examples of polynomials. And then after that, I will discuss classification of polynomials in two aspects, but depending on the number of terms you have and also the order of the degree. And then after that, we will look at algebraic operations on polynomials. And then we will end the lesson by looking at some applications of polynomials. So definition. A polynomial is any expression of the form, an expression of the form should have said a polynomial in a variable x, an expression of the form px some an x to the n plus an minus 1 x to n minus 1 plus a2 x squared plus a1 x plus a0, where ai are real coefficients and the n is an integer. ai are real coefficients and n is an integer. So let me give you examples of polynomials, and also I'll give you some expressions which are not polynomials so that we understand what I mean by a polynomial. Example. For example, the expression like 2x cubed x plus 5. This is a polynomial. As you can see, the coefficients. So in this expression, a minus 1, a2, a1, a0, these are called coefficients, and they are real values. And then,
do you mind writing a bigger numbers?
Okay.
Some of us are quite old, so our advantage don't allow us to see small numbers.
Is this visible?
That is visible, but then equal, after equal, nothing.
After equal, okay.
Yes. Thank you.
So we have an x n plus n minus 1. Is that better?
Yes.
I do it worse.
Yes, that's better. Thank you.
a2 x squared plus a1 x plus a0. Of course, here there is an x to the 0, but x to the 0 is 1, so I just write a0. And I've said the an's, an minus 1, a2, a1, a0, they are called coefficients. And for our case, they will be real numbers. So that's why I write ai belongs to R. ai belongs to R, they are real coefficients. And the exponents or the powers of this unknown variable are integers, belong to Z. And for this case, they should actually be positive integers. Let us deal with positive integers. So for example, 2x cubed plus 4x plus 5, an expression like x plus 1, an expression like 10x to the 9, that's a polynomial. Let me give you examples of expressions which are not polynomials. Are not polynomials. An expression like 2x a half plus 6x. This is not a polynomial. Can someone tell us the reason why this is not a polynomial? Why do you think this expression I've just written is not a polynomial? Based on our definition.
Because it's not a positive natural number. You can't have a half as an exponent. It has to be a natural number.
Yes, a half is a rational number. So this one is not a polynomial. How about x plus 7? How about square root of x plus 7? Is that a polynomial?
No, it's a radical.
It's a radical. What do you mean by radical?
Sir, please repeat, sir.
Yeah, just before I repeat myself, why is this not a polynomial? Root of x plus 7.
Can I try?
Yeah.
It's still the same reason, because square root of x can be written as x in the power of 1/2.
Yes.
So 1/2 is still not a natural number.
Yes, that's true. How about square root of too much square roots? Maybe 2x plus 5x cubed minus x power 5/4. For the same reason, that will not be a polynomial. Abdi Hakim, what should we repeat?
Sir, from the beginning.
In the beginning.
Yeah.
Okay. So I've just given a definition of a polynomial, and the definition is very simple. A polynomial in a variable x, which could be known or could be unknown, is an expression of the form px is an x to the n plus an minus 1 x to the n minus 1. And then this dot means you continue. There are more terms. So that's why I put these dots. It continues. So you will have an to the 2 n minus 2 x n minus 2 an minus 3 x to the n minus 3 all the way up to a2 x squared plus a1x plus a naught. Of course, here there is a naught and then there's an x to the 0, but I don't want to write x to the 0 because it's simply 1. As we shall see in indices, any number raised to power 0 is simply 1. And we are saying that these coefficients, so this an, n minus 1, a2, a1, they are called coefficients. We want them to be real numbers, any real number. And then we want these guys to be positive integers, or simply natural numbers, these exponents or powers of the unknown variable. For example, an expression like 2x cubed plus 4x plus 5. In this case, your coefficients are 2, which is a real number, 4, which is a real number, and 5. And your exponents are 3, which is a natural number. Here we have 1, and of course here we'll have a 0. The second example, the coefficients are 1 and 1, and the powers are, this is x to the 1, and this is x to the 0, which are like positive integers. In the last example I've given, 10x to the 9, the coefficient is 10, which is a real number, and the power of the exponent is 9, which is a positive natural number. Then I've given you examples of expressions not considered as polynomials. So for instance, 2x to the half plus 6x is not a polynomial because a half is not a natural number. For the same reason, square root of x plus 7, and these are the expressions also not a polynomial. And maybe another common example is 1 divided by x. 1 divided by x is the same as x to the power of -1. This is not a polynomial because -1 is not a natural number. So just bear in mind that for polynomial, the exponents or the powers of the unknowns must be positive integers or natural numbers. And then the coefficients, for this case, we are taking real values or real numbers. So the coefficients are allowed to be, for example, pi can be a coefficient. I can have a polynomial, let's say pi x to the plus maybe e x, where pi and e are irrational numbers. Any question before I move to the next?
I have a question.
Yes.
So I would like to know if, for example, there is square root of 9x squared plus 3. Is it a polynomial or not?
Just a minute. You said square root of? Come again, please. Square root of.
Sorry, 9x squared.
9x squared.
Yeah, plus I don't know 8, not inside the book. Yeah.
Under the root, okay, and then
I don't know but plus 3, not under the square root. The plus is not. Yeah.
like
Is it a polynomial?
You're asking if this is a polynomial.
Yes.
Okay, first of all, what is square root of 9x squared?
It's
3x.
X.
It will be equivalent to 3x plus 3.
Yeah.
3 is a real number. And x has an exponent 1, which is a natural number. 3 has an exponent. Of course, there's an exponent 0 there. So this is a polynomial.
I asked this question because maybe people are confused with the fact that you're saying that every square root is not a polynomial. Let's say if we have a quiz and we see a square root, people might think that it's not a polynomial just because there is a square root. So I just wanted to clarify that.
Yes, I feel what you're saying. So when you meet this square root or radicals or someone mentioned, make sure you work it to the simplest form, but you cannot simplify it any further. Then from there you can make your conclusion as to whether it's a polynomial or not. This one I was able to simplify as 3x plus 3, and I can't simplify it any further.
So what if it is it is a number which doesn't have a square root?
Like what?
Not the one with the point.
Like what? Like which number? Give me an example.
10.
Give me an example.
10.
10. So you want square root of 10 x squared plus maybe 4, for example. You're asking if this is a polynomial.
Yes.
Yes, this will be a polynomial because this is the same as square root of 10 x plus 4. Remember, square root of 10 is a real number. It will be irrational, as we have seen in the previous lectures, but square root of 10 is a real number. So this qualifies to be a polynomial. We're only interested in the powers. Is the power a natural number or a positive integer? If so, and then as long as the coefficient is a real number, you get a polynomial.
Why is it not a polynomial when it has a half as a power?
Which one?
The other example that you gave before, like 2x power a half.
2x power a half.
Yeah, plus 6x.
Yes, this is not a polynomial because of this term. You have the unknown variable has an exponent which is a half. Maybe let me repeat what's a polynomial. The exponents or the powers to which the unknown variable is raised must be natural numbers or positive integers. Okay? The coefficients could be any real number that you know of. So in this case, the coefficients are okay. 2 and 6 are real numbers. The power of this, okay, it's 1, but the power of this is a half. And a half is not an integer. A half is not a natural number. That is why this is not a polynomial. When you have an expression like 1 over x, which I said is the same as x to the power negative 1. This power negative 1 is not a natural number. It's not positive. So this is not a polynomial for that reason. Okay, so always check the powers. The powers must be natural numbers or positive integers. Coefficients could be anything as long as it's a real number. I hope that makes it clear.
I have another question.
Yes, another question, please.
Where are you taking this square signs? For example, there are 9x squared plus 3 and 10x squared plus 4. And then when you simplify, I don't see that square sign.
You don't see the square sign?
Yeah.
So square root of 9, we look at, yeah, that's a good question. That's a very good question. We will look at properties of sum of these real numbers as we go along. So if you have any real number a and b, square root of a and b is the same as square root of a times square root of b. We will do this when we are studying radicals, as someone had mentioned earlier. So if you take a to be 9 and b to be x squared, then square root of 9x squared is the same as square root of 9 times square root of x squared. Well, square root of 9 is just 3, and square root of x squared is x. That is why here I have 3x. And for the same reason here, I will have square root of 10 times x. This is the law I've used. Don't worry if you don't understand this. We will come back to this when doing radicals, where we will prove this. We'll prove this formula of this relation. But this is the law that I've used. Is that better for you?
So I have a question.
Yes.
Yeah, I understood.
So can you do an example where for a base n, and then
Example where?
a base n and then x power n minus 1.
X power?
A to base n, and then you have
X power n minus 1.
yeah, for the form you gave us. Form a base 10.
Where
And
a is?
A to base n.
A is what?
A to base n.
N to base n.
No, for the Nini you gave us example of Nini.
My definition of polynomial.
Yeah. A to base n, and then x n minus 1.
No, don't confuse this with bases of logarithms. That is not base. When I write there's not a base here. When I write a sub n, this is just a sub index. This is not a base. Okay, I'm just listing s. This is not a base, please. This is not a base for logarithms. I could as well have written p. I could have written our polynomial as px is something like maybe h x to the n plus p x to the n minus 1 plus z x to the 2 plus maybe r x plus maybe q, where h, p, z, r, and q are numbers. This is not a base, please. This is not a base. I don't know whether I got your question.
Yes, sir.
So what do you want us to do now?
I wanted to see how you can express with the numbers.
How you can express what numbers?
With numbers, like where you change from a to maybe 3.
Where I change from, I don't.
You want you to use actual numbers instead of.
I don't quite understand your question. I don't quite understand your question. For example, an expression like maybe 10 x to the 10 plus 11 x to the 9 plus 5 x to the 6 plus x. This will still be a polynomial. This will, because the coefficients are 10, 11, 5, and 1. Those are real numbers. The exponents are 10, 9, 6, and 1, which are positive integers or natural numbers.
Sorry, sir, I have a question.
So
if I go back to your definition, you say that n should be part of positive relative numbers. I don't know if it's a different in terms of notations in French and English system, but from what I understand what you wrote is that n should be part of positive relative numbers, right? Not natural numbers.
Natural numbers and positive integers, it's the same set.
Are the same. Okay.
The same. How do you have
And something we are trying to discuss, does it include 0?
0? Yes, of course, 0 is included. When you have, for example, an exponent, x plus 1, one of the exponents here is 0. Remember, this is the same as 1 times x power 1 plus 1 times x power 0. So the coefficients are 1 and 1. The exponents are 1 and 0. You will learn later in this course that any number raised to 0 is always 1. So 0 is part of the exponents in the definition of a polynomial. Okay?
So can we say that every natural numbers are polynomials? Can we say that? Because the exponent of x is 0.
Yes, that's a good observation. Every natural number is a polynomial, and we are just about to look at classification of polynomials. That's a very good observation. You are right. Shall we proceed? Unless there are some more comments.
We can proceed.
So sorry, I have one question. It's just, can the coefficient be a fraction?
The coefficients can be a fraction, yes. So if you have a polynomial, let's say I have x plus 1. This is a polynomial, and the coefficient is a fraction. The coefficient can be any real number. And we said a real number is a number which is rational or irrational, and that includes natural numbers, all the integers, okay? All the fractions, positive and negative.
All right.
So the coefficients can be irrational. They could be fractional. Okay. And then I should also mention that in this week we will be having the first takeaway assignment. It's there on the Blackboard. So please make sure you observe that. And by the end of this class, you should be able to solve all the problems in that first assignment. So next, we look at classification of polynomials. Classification of polynomials. Classification of polynomials. There are two criteria for classification. The first one is according to number of terms. According to number of terms. According to number of terms. Sorry, I did not mention this. I did not, but I will repeat them. No problem. So we are saying a polynomial is any expression of this form. N x to the n plus 1, x to the n minus 1, all the way to this guy. So the terms are these. These are the terms. This is a term. This is a term. This is a term. That's a term. That's also a term. And then, so a term is simply the product of a coefficient and their non-variable raised to some exponent. The powers are called exponents. So in classifying according to number of terms, you simply count the number of terms in your polynomial. Let me give you examples to make this clear. So the first classification, we have monomials. Monomials. Mono from the word one. So these are simply polynomials that have only one term. Example, a polynomial like x. A polynomial like 3. This is a monomial. A polynomial like x to the 10. A polynomial like x to the 6. These are examples of monomials. They only have one term. Okay. So all the other terms have 0 coefficients, so they have disappeared. And these are the only terms that have non-zero coefficients. A polynomial like 100 x to the 3. These are what we call monomials. So monomials have one term. One term. Then we have what we call binomials. Binomials. From the word bi, these ones have two terms. Have two terms. For example, x plus 1 is a binomial. X cubed plus x is a binomial. X power 100 plus x to the 6 is also a binomial. So any expression that has only two terms, which these two terms satisfy the definition of a polynomial, is called a binomial. Then proceeding in a similar fashion, we have trinomial. Tri from the word three, these ones have three terms. An example, 2x squared plus 4x plus 5 has three terms, so it's a trinomial. Example, x to the 6 plus x plus 1 has three terms, so this is a trinomial. So monomials have one term, binomials have two terms, and trinomials have three terms. You just count the number of terms in your expression.
Excuse me, sir.
Yes.
Can one term have more than one exponent?
Sorry?
Can the term have more than one exponent?
One, not really. No, I don't think so. Maybe I don't understand what you're saying. If a term can have more than one exponent.
Variable.
Or you mean variable?
Pardon?
Do you mean variable? Let me rub this. Do you mean variable? Or are you asking for expressions like pxy is 2x to the 6, x to the 5 plus maybe 6xy? Are you asking for expressions like this?
Oh, I'll ask you about not the variable, the exponent. Like, can it be 2x, 6, command 3? I was asking.
2x3? And then?
Like the exponent 3 here, right?
2x.
The exponent.
2x cubed and then?
Yeah.
And then what?
I'm asking if this monomial can have two exponents. If it's possible for a monomial to have two exponents?
Maybe something like x squared like that.
Yeah.
This is what you're referring to?
Yes.
Yeah, if this, then it's true because this is the same as 2x to the 5. But avoid expressions like this. They're not very useful. Okay, just simplify. Lots of indices are the best enough to simplify. I thought you were asking about having more than one variable. In case it has more than one variable, we'll call them multivariate polynomials. And in this course, we will not consider multivariate polynomials, where you could have two unknowns x and y, three unknowns x, y, and z, maybe four unknowns. For this class, we will only deal with one unknown. The fourth classification under number of terms, we call this in general n.
Excuse me, sir.
Generally, we say n term polynomial. So if a polynomial has if a polynomial has more than 3 terms, say n, but it as n term polynomial. So for example, say you have x to the 4 plus x to the 3 plus x to the 2 plus x. This has 1, 2, 3, 4. So this is called a 4-term polynomial. 4-term polynomial. Maybe another example, x to the 5 plus x to the 4 plus 2x to the 3 plus 10x to the 2 plus x plus maybe 8. So this has got 1, 2, 3, 4, 5, 6. This is called a 6-term polynomial. So classification of polynomials according to number of terms, very simple. If it has 1 term, monomial, 2 terms, binomial, 3 terms, trinomial. And then when the number of terms is more than 3, just change, just use the number as an ordinal. So 4 term, if it has 4 terms, 6 term, if it has 6 terms, 5 term, if it has 5 terms, 100 term, if it has 100 terms. Then the next criteria for classification will be according to
raise it down, Sarah. Excuse me, sir. Excuse me.
Yes, you're excused.
Yes, you are recording the class, right?
Just a moment, we can change something. Are you able to see my new board?
Yeah.
No.
Yes.
Yes.
You cannot see my new board.
We can see.
Maybe I should write down.
Excuse me, sir, I have a question.
How about if I write here?
That's fine.
This is fine. Okay, okay.
Excuse me, sir, I have a question.
Yes, ask your question.
What about the polynomials that are like a to the base of n minus 1 and x to the power of n minus 1? Does it fall under monomials?
Which polynomials?
The ones like a to the base of n minus 1, x to the power of n minus 1. Where does it fall under?
I understand you. Okay, so my general definition was any expression a n x to the n plus a n minus 1 x n minus 1.
Yeah, the second one now.
Plus a3 x cubed plus a2 x squared plus a1 x plus a0. Is this what you're referring to?
I'm referring to the second one.
Which second one? This one?
After, yeah, that one.
Second term.
Yeah, so is it a monomial or where does it fall under?
Well, if you take it the way it is, it's a monomial. But if you take the whole expression as it is, it's a monomial with n plus 1 terms. So this will be an n plus 1 term polynomial.
So it will fall under the n term polynomial.
No. This will be an n plus 1 term. If you count them, 1, 2, and then there is this n, so it will be n plus 1.
Okay.
Yes. For example, let n be 5. Huh? then you will have something like a5 x to the 5 plus a4 x to the 4 plus a3 x cubed plus a2 x squared plus a1 x plus a0. Count these terms: 1, 2, 3, 4, 5, 6. 6 is the same as 5 plus 1. So in general, if you have if you have all the exponents from n up to 0, then you have n plus 1 term. And this is assuming that all the terms in the middle have non-zero coefficients. Now, according to now let's look at classification of polynomials according to degree. So if you have the expression, maybe let me give some definitions before. A2 x2 plus a1 x plus a0. So definition. When an is not 0, then px is said to be of degree n or order n. So when this coefficient of the x to the n is non-zero, then we will refer to our polynomial as of degree n. The examples that we looked at: x cubed plus x4 plus x. So in this case, the term that has the highest exponent is 4. So this is a fourth order polynomial. This is of degree 4. Degree 4. An expression like x plus 1, this is of degree 1, because the highest exponent is 1. An expression like x to the 6 plus x, this is of degree 6, because the highest exponent is 6. So the classifying polynomials according to degree, when you have this expression, if this coefficient of the term having the highest exponent is non-zero, then that polynomial is said to be of degree n or of order n. And now, this is how we classify polynomials based on their degrees. They will slightly follow the ordinals of the Latin language. So there are some of you who have learned Latin, this will be easy for you. So let me have n. This is by calling degree. Then let me have the name of classification, and then I give an example. Zero. So polynomial of degree 0 is called constant polynomial. Someone asked a question: are all natural numbers polynomials? Yes, they are polynomials and they are called constant polynomials. So an example, maybe 2. 2 is a polynomial. It's a constant polynomial. For degree 1, we have linear polynomials. For example, x plus 1. It's linear because the graph of this expression will be a straight line. Of course, we can also graph constants. It will be simply a constant graph, which is a horizontal line. Degree 2, we call these ones quadratic. For example, 4x squared plus 2x plus 1. This is degree 2. So the highest exponent is 2 and it has a non-zero coefficient. So this is called a quadratic polynomial. When the degree is 3, we refer to it as cubic. Example, x cubed plus 4x squared plus 2x plus 6. You can go on and on. When the degree is 4, we call it quartic. For example, x to the 4 plus 1. When the degree is 5, we call it quintic. So for example, x to the 5 plus x to the 4 plus 10. When the degree is 6, we call it hextic. Some books will call this sextic. Example, x to the 6 plus 7x plus 5. So I'm just looking at the term with the highest exponent. If it has a non-zero coefficient, then that will be the degree of the polynomial. Let me.
So I have a question.
This side and name an example. So we go up to 7, 9, 10, 11, and you allow me to stop at 12. So when the degree is 7, we call it septic. Example, x to the 7. When the degree is 8, we call it octic. Example, x to the 8 plus 5. When the degree is 9, we call it nonic. For example, x to the 9 plus 7. When the degree is 10, we call it decic. For example, x to the 10 plus 5. When the degree is 11, we call it undecic. For example, x to the 11 plus e. When the degree is 12, we call it the basic. For example, x to the 12 plus x to the 10 plus maybe 4.
Sir,
And it goes on and on. Yes, please.
I have a question. The way you're saying, when you're saying when x has a 0, what's that word you're calling it? A 0 something, what do you mean? Like for it to, yes, a non-zero.
I'm talking about non-zero coefficient.
Yeah.
For example, this constant polynomial, I could write here 0x to the 10. So my term with an exponent 10 has a 0 coefficient. This is the same as just writing 2.
Oh.
Yes, so when you have, for example, x plus 1, the coefficients we have 1 and 1, they are non-zero. There could be other terms, like let's say 0x to the 6, but they have 0 coefficients, so they are ignored. Okay?
Yeah, okay, I
We
understand.
only consider terms that have non-zero coefficients. The ones that have 0 coefficients have been ignored. Okay? For example, in this case, you could have maybe 4 more terms, but all of them have 0 coefficients. For example, there is no x squared term, there is no x cubed term, there is no x to the 4th term, there is no x to the 5th term. It means all their coefficients are 0. I'm only interested in the ones that have non-zero coefficients, 1, 7, and 5. Okay?
Yes, thank you.
So for now, these are the classifications we will look at: constant, linear, quadratic, cubic, quartic, quintic, hextic. This actually follow the Latin ordinals. So those of you who have done Latin or are interested in Latin may go ahead and continue with this list.
Excuse me, sir. I have a question.
Go ahead.
So just to confirm, the degree ends are being named according to the highest n degree. So for example, the one that's cubic, the third one, the reason why it's cubic is because the highest power is 3.
Yes, that's true. This is quadratic because the highest is 4. This is quintic because the highest value is 5. This is sextic because the highest is 6. Actually, any polynomial, if you want to classify according to the degree or the highest exponent of the term, just look at the term that has the highest exponent and the non-zero coefficient. That should give you the classification. Okay. So next we have algebraic operations. Algebraic operations. And polynomials. This will be quick because you've done the exercise on vector space. So the set of polynomials is actually a vector space, which means you can add up 2 polynomials and end up with a polynomial. You can multiply a polynomial by scalars, or real numbers, and end up with a polynomial. So effectively, it's a vector space. Let me combine addition and subtraction. Addition and subtraction. We only have 4 algebraic operations. In general, given P of X as some an x to the n, that's a minus 1 x to the n minus 1. That's a naught. And qx as some bn x to the n plus bn minus 1 x to the n minus 1 b1x plus b naught. Then px plus or minus qx given by an plus or minus bn x to the n plus an minus 1 plus or minus bn minus 1 x to the n minus 1 plus a1 plus b1 x plus a naught plus or minus b naught. So what this expression tells you is that when adding or subtracting 2 polynomials, simply add coefficients of the same exponent, of the terms that have the same exponent. You add and subtract the coefficients of the terms that have the same exponent. Let me give an example.
Is it the same like as adding like terms?
Yes, it's the same as adding like terms.
Okay.
But I want to refer to this as terms, refer to them as the terms that have the same exponent. For example, let's say you have a polynomial px is 2x plus 6, and qx is maybe x plus 7, x squared plus 13. We want to add these polynomials. So this relation tells us that you add and subtract coefficients of the term that has the same exponent. So firstly, Q of x plus Q of x. Of course, this will be 2x plus 6. You're adding these two, x plus 7x squared plus 13. Well, this is the same as, so there is no x squared this side. I only have an x squared that side, so I have 7x squared plus, there's an x, so I'll have 2 plus 1x plus the constant, guys, 6 plus 13. This gives me 7x squared plus 3x plus 19. Very simple. Just identify coefficients of terms that have the same exponent and add.
Sir, could you please repeat?
Please repeat.
Lost. Please repeat.
I repeat. Okay, maybe I do it in a different way. Right, I want to do it vertically. So this is the same as 2x plus 6. And this side, we can rearrange this. We know that addition is commutative. Huh? When you add 2 to 6, the same as adding 6 to 2. So I could write this as 7x squared plus x plus 13. Then we do this, what you did in, I don't know whether it's high school or primary school. Just to the vertical addition, 6 plus 13 is 19. 2 plus 1 is 3. And then 7 plus 0 is 7x squared. So that's the sum of polynomials. So what I did over here, I was given px as 2x plus 6. And I was given the polynomial of q with x as x plus 7x squared plus 13. And the rule for adding is that identify the terms that have the same exponent. Okay? So for example, the constant term on the first polynomial is 6. Constant term, and the constant term on the second polynomial is 13. So I will have 6 plus 13 giving me 19. The coefficients of x, so the linear terms will be 2, this side and this side we have a 1. So I take 2 plus 1 giving me 3. And then there is no coefficient of x squared on this guy. There is only one coefficient of x squared, 7. So I have 7x squared plus 3x plus 19. Similarly, px minus qx, you will do 2x plus 6 minus x, 7x squared plus x plus 13. Of course,
excuse me, so isn't it supposed to be 3x, not x, like 7x squared plus 3x plus 13, oh, plus 9. Oh yeah, sorry, you're right.
Are you okay?
Yeah, I'm okay.
Yes, okay. So start by opening the brackets. Remember BODMAS. This is 2x plus 6 minus 7x squared minus x minus 13. Then now I want to collect like terms as someone was mentioning. Just put together everybody that has the same exponent. So I have minus 7x squared plus 2x minus x plus 6 minus 13. I'm doing this because addition is commutative. So whether you start from the left going to right or from the right going to left, when adding two terms, you get the same result. So this is minus 7x squared plus 2x minus x is simply x.
X.
6 minus 13 is simply minus 7. So you get minus 7x squared plus x minus 7. We could do it like we did this one over here. So 2x plus 6, and then we have 7x squared plus x plus 13. Then we subtract. Of course, 0 minus 7 is minus 7x squared. 2x minus x is x. And then 6 minus 13 is
minus 7.
Same result. Is that okay? Shall we do more examples?
No, that's enough.
Is this enough? Huh?
Yeah.
Okay, so addition and subtraction, just identify coefficients for similar exponents. Then proceed as usual. The next operation is called scalar multiplication. So remember, we are in a vector space. And in a vector space, as you have seen, we have been able to add two polynomials to get another polynomial. How about now scalar multiplication? Scalar multiplication. Scalar multiplication. So in general, given a polynomial p of x, so let's say an x to the n plus a1x plus a naught, and the scalar maybe alpha, the real line, then alpha times p of x. Well, simply scale each of the coefficients. So we'll have alpha an x to the n plus alpha x plus alpha a naught. Just multiply each of the coefficients by the scalar. Example, let s of x maybe x power 7 plus pi x cubed plus ex minus 19. Then I ask you to compute 5 s of x. Just multiply each of the coefficients by the scalar. So we'll have 5, of course I'll have 5 into x to the 7 plus pi x cubed plus ex.
Excuse me, sir, you've lost me.
See? Go ahead.
Could you start again?
From where?
From given p bracket x.
Talk louder, please. I'm really straining to hear you. Can you?
From given p bracket x is
Oh,
equals to...
okay. So the next operation is scalar multiplication, multiplying polynomials by scalars. Scalars are simply those quantities which have magnitude but no direction. For example, real numbers. All real numbers are scalars. So we are saying given a polynomial of the form maybe anx to the n plus up to the n of term and a real number or a scalar alpha. If you are asked to find a scalar multiple alpha of px, then multiply each of the coefficients by alpha. So I will have alpha anx to the n plus all the way to alpha a1 plus all the way alpha a0. I keep multiplying each of the coefficients by this scalar. Example, let me give you a polynomial s of x, x to the 7 plus pi x cubed plus ex minus 19. You all know pi, the ratio of reference to the diameter, and then e, this irrational number we talked about. So these are polynomial because these ones are real numbers. Okay. So we want 5s of x. Well, we are saying that simply scale each of the coefficients by the scalar. In this case, the scalar is 5. So we just multiply each of the coefficients by this new scalar. So the coefficient here is 1 times 5, get 5, x to the 7. This is pi, so we get 5 pi x cubed. This is e, so we get 5e x minus 19. What is 19 times 5?
95.
Very simple. Just multiply each coefficient by the scalar. Is that okay?
Yes, it is.
Is that example enough? You want another one?
One more, please.
Question. I have a question.
Mm-hmm.
There where you've written the result, where it's 5x to power 7 plus 5 pi x to power 3. Can you solve that, or do you just leave it like that? 5 pi, can you actually multiply it instead of leaving it as 5 pi?
It's more advisable to leave it like this because, as I mentioned in one of the classes, there is no man alive at the moment who knows the exact value of pi. And even e. We have been able to compute the value of pi to 13 billion decimal places. So no one knows the exact value of pi. Just leave it as 5 pi. And even e is also irrational. Just leave it as 5e.
Okay, thank you.
Unless you are asked to approximate. Of course, when you do approximation, there are errors. So you must also state the error of your computation.
Okay.
Scalar multiplication is.
I have a question.
Yes.
For the multiplication is there for it only.
Sorry?
For multiplication only, no need for scalar multiplication.
Uh-huh. Go ahead.
Must it be scalar multiplication?
No, there is also multiplication of polynomials, which is the next thing.
Okay.
Yes, there is also multiplication of polynomials.
Sir, could you do one more example of the scalar?
Another example.
The last one. Yeah, the last one.
Okay, another example. Take the polynomial 2x cubed plus 4x squared minus 6x plus 10. Then simple, compute 3px. Just multiply everything by 3. This will be 3, 2x cubed plus 4x squared minus 6x plus 10. And so we are getting 6x cubed plus 12x squared minus 18x plus 30. I've just multiplied each coefficient by this scalar.
And the 3, where is it from? Is it the power of 2x? That's why we get the 3.
No. 3 is just some.
You just compute.
Just some random number I've chosen. I could have chosen 5. I could have chosen 10. I could choose 20.
So you choose any number.
Yes, I can choose any number.
So in an exam situation, whenever you give us a question and you give us that alpha is a real number or something, we just use any number.
No. In the exam, I will give you a scalar. I will give you a scalar to use. I'll tell you maybe use alpha is 5 or alpha is 6. Or alpha. I will give you.
Okay, thank you.
Multiplication of polynomials. Multiplication of polynomials. So let P of x some an x to the n plus a on x plus a naught. Let Q of x some bm x to the m plus b1 x plus b naught. Then the product px times qx will be, so you're multiplying an x to the n plus a1 x plus a naught. We're multiplying this by bm x to the m plus b1 x plus b naught. So this is where now you have to remember what we did with scalar multiplication. You want to take all these terms, each of the terms on the left-hand side, multiply by each of the terms on the right-hand side, okay? You're taking each of these terms on the left-hand side and you multiply by all of the terms. So I want you to treat each term maybe as a scalar. Use it to multiply the term on the left, on the right-hand side. And then after that, add all the terms that have the same exponent. If you do that, you will get an bm x to the m plus n plus all the way to a1 b1 x plus a naught b naught.
Sir, can you please repeat this?
Yes, I will repeat this and even give an example. So you take all the terms on this left-hand side and you multiply by the terms on the right-hand side. So the simplest way to do this, treat each of these terms as a scalar, as we did in scalar multiplication, and use it to scale the coefficients of the term on the right-hand side. So I will start with first the term an x to the n. Okay. So how I got this first term, I took an x to the n, I multiplied this by bm x to the m. An and bm are real numbers, so we have an bm and then xn xm. So
But the letters.
the law of indices, I will have x power n plus m. That will be the first term. Then again, I will take an and multiply by all these other terms. After some finite number of steps, I will come to a1 times a1. Actually, this step is not right. Plus a1 b naught plus a naught b1 x. Yes, this is okay now. Let me give you an example. To be more clear, if I give you a concrete example.
Sorry, sir, could you please enlarge on what you just added to the equation?
What I've added here is a1 b naught plus b1 a naught x plus a naught b naught. Example, take px to be 2x plus 3. I want to start with the simplest example. And then take qx to be, let's say, x. So here I have to give more examples because it's a bit, things might get complicated from here. So px times qx, well, that is the same as 2x plus 3 in bracket multiplied by x. Then here, just open the bracket, take each term on the bracket and multiply the term outside. So I will have 2x times x plus 3 times x. And this is simply 2x squared plus 3x. So
Sir, please repeat.
This multiplication.
Yeah.
Yeah, so we are multiplying two polynomials, a linear polynomial 2x plus 3 and a monomial x, which is of degree 1. And the idea is to take each coefficient of the first polynomial and multiply each term of the first polynomial and multiply by the terms of the second polynomial. So our first polynomial is 2x plus 3. Our second polynomial has only one term, x. So I will take the first term 2x multiplied by x. 2x times x, that gives me 2x squared. And then 3 times x is simply 3x. Of course, in this case, x squared, when I write x squared, I'm referring to x times x. Let me give another example. So maybe let a polynomial x plus 1, bx, x minus 1. We want to multiply. So you want ax times bx. This will be x plus 1 times x minus 1. Then now you take each term of the first polynomial are multiplied by all the terms of the second polynomial. So usually you open brackets like this, take x times x minus 1 plus 1 x minus 1. Okay, the first term is x. I use it to multiply all the terms of the second polynomial. So x times x minus 1. The second term is 1. I use it to multiply all the terms of the second polynomial. So 1 times x minus 1. And then now x times x is x squared. Just open the bracket. X times minus 1 is minus x. 1 times x is x. 1 times minus 1 is minus 1. And then you realize that minus x plus x is 0. So this will give you x squared minus 1. Let me give one last example. Let's see of x, 2x plus 7x squared. Let d of x maybe x squared plus 6x plus 10. The procedure is the same. So you are expected to compute cx times dx. Well, just write cx is 2x plus 7. And then dx is 2x plus 6x plus 10. Allow me to rearrange this so that the highest order, the highest exponent comes first. 7x squared plus 2x. So we take the first term 7x squared and multiply it by all the terms of the second term, the second polynomial, plus 2x x squared plus 6x plus 10. That is your first step. Take each of the terms of the first polynomial and use it to multiply all the terms of the second polynomial. And remember, this procedure is commutative. I could also start with x squared plus 6x plus 10 and do it the other way around. Because multiplication is commutative, you will get the same result. And so now 7x squared times x squared, well, that is 7x to the 4 plus 7x squared times 6x, that is 42x cubed. So 7 times 6 is 42. X squared times x is x cubed. That is why I have 42x cubed. Plus 7x squared times 10. That's just scalar multiplication. 10 times 7, that is 70. And then I have x squared. plus, so I'm done with the first term. I'm done with taking the first term and multiplying it by the polynomial. Then 2x times x squared is 2x cubed plus 2x times 6x. So 2 times 6 is 12. And then you have x times x, that is x squared. And lastly, 2x times 10, that is just scalar multiplication.
20x. Where you wrote 42x cube.
Sorry?
Isn't it meant to be square?
Here.
Yes.
It is x cubed because I have x squared times x. This is x squared. Huh? Then there's an x. So when you take x squared times x, you get x cubed.
But isn't it 2 times 1, the one that is on top of the x?
This one?
No, the 6x, the one that's meant to be on top of the x but is not written.
Yes. No, you add. You don't multiply. You add.
No.
That's for addition, actually.
In general, you have x to the m times x to the n. This would be x to the m plus n. So that is why if I have x squared times x, which is simply x to the 1, it's going to be x to the 2 plus 1, which is x cubed. If I have x squared times x squared, this is going to be x to the 2 plus 2, which is x to the 4. Okay. Maybe another example, if you have x to the 6 times x to the minus 2, it's going to be x to the 6 plus negative 2, which is x to the 4. And then now you combine all the coefficients of the same exponents. So we have 7 x to the 4 plus, so 42 plus 2 x cubed. So I've taken this term, because they have the same exponent, so I will add their coefficients, and then plus 70 plus 12 x squared. I've taken this guy and that guy. Then lastly, plus 20 x. So this gives you 7x to the 4 plus 44 x cubed plus 82 x squared plus 20 x. So the first step, your goal is to make sure that each term on the left-hand side is multiplied by all the terms on the right-hand side. And as I have said, and I'm repeating, this process is commutative. So I could also start with the second term and then followed by the first term, and I will get the same result because multiplication is commutative. And then now I take 7x times all the terms on the right-hand side plus 2x times all the terms on the right-hand side. And then you open brackets, and you also take note that when you're multiplying two monomials with order m and n, your result will have a sum of the exponents. So x times x squared is x cubed. X squared times x squared is x to the 4. X to the 6 times x to the minus 2 is going to be x to the 6 minus 2, which is x to the 4. And this process at times gets very painful. And for that reason, there are softwares which help you do these polynomials. You could do this in Python, for those of you who know how to use Python. You could also do this in Sage. You could also do this in MATLAB, Octave, Scilab. All these are softwares which can help you to multiply polynomials of higher orders. Because the beauty in mathematics is not laboring in doing such long computations. There are computer softwares that can help you with this. Because depending on the type of problem you have, we sometimes get very crazy polynomials. A polynomial, for example, with 200 terms. It will be unrealistic to multiply that by hand, okay? Any question on multiplication of polynomials? The procedure is very simple. Just make sure that you take each term of the first polynomial, multiply by all the terms of the second polynomial, and then add up everybody who has the same exponent, every coefficient who has the same exponent. Any question on multiplication of polynomials? Are we there? Questions?
No.
No questions?
No.
Yeah, no questions.
Okay.
Okay.
Good. Now let's move to the last bit of our today's class. This is division of polynomials. Let P of X n x to the n is n naught and Q of X bm x to the m plus bx plus b naught. Let those be polynomials. Such that.
Could you please enlarge on your numbers?
Such that m is less or equal to n. I hope you understand what I mean by m is less or equal to n.
Yes. Yes, we do.
Are we all at peace with this?
Yeah.
Okay. Then px divided by qx can be evaluated by what we call just long division. Let's do long division. For example, take p of x the x squared the x cubed plus x squared, and take q of x the x. So in this case, we are safe because the highest exponent here is 1, the highest exponent here is 3, and 1 is less than 3. So we are good to go. Px divided by qx. Well, this is we are going to evaluate x cubed plus x squared divided by x. So how do you do long division? Long division dividing x cubed plus x squared. So how many times does x go into x cubed? Because that's x squared. So this gives you x cubed. And then you subtract this side, you have x squared. Of course, this side you have 0. Then how many times does x go into x squared?
X.
X.
One time.
One times.
Sir, I'm lost at
Two
this long
times.
division.
You're lost at?
Just there from where you started the long division.
You're
There, I'm
lost?
a bit confused.
Long division.
Like at the example,
At the example. So is it long division
yeah.
problem?
Like I'm a bit lost. Could you please explain?
Have you done long division before? Long division of numbers?
I think so, yeah.
Okay, let me take you through long division of numbers. It's the same concept that we're using here. So what we have, let's say we have 20. So I want to evaluate maybe 120 divided by 20. Is this a good example? 1,200. So I have 1,200, then I have 20 outside. Then you start from 1. Can 20 go into 1? No.
No.
Go into 12?
No.
Can it go into 120?
Yeah.
Yes. How many times?
6.
6. And that gives you 120. And then, of course, yes, of course.
0.
0.
Then you drop the 0, then you put the 0 at the top. Because it can't go through the next number, you put a 0 at the top.
Is there a way to do that doesn't involve dividing?
No, that's not what I'm worried about. I'm worried because this is not going to work for the polynomials I'm giving you.
Yeah.
You can just use the example that you had before and then like explain with that example. But I get what you mean by long division.
This analogy is not going to work for me in this case. Because you'll get a 60, but the analogy is not going to work. Well, what I'm trying to say is that you have to divide x cubed plus x squared. You have to divide this by x. And so through long division, if we had done factorization, this would be very simple, but factorization is our next topic. So here we have x cubed plus x squared. So for polynomials, it's going to be easy because you can do it term by term, okay? You normally start with the term that has the highest exponent. So x will go into x cubed, x squared times. The reason for that, I gave you the law that if you have x to the m times x to the n, this is the same as x to the m plus n. And if you want to see how this comes about, x to the m is simply x times x times x. You do this m times. Then x to the n is simply x times x times x. You do this n times. So you have x listed m times and x listed n times. In total, you'll have x listed m plus n times. That is why we have x to the m times x to the n is x to the m plus n. This is the intuition, but there's a formal way to prove this, but this is the intuition I can give you for now. Using the definition that x to the m is simply x multiplied by itself m times, and x to the n is x multiplied by itself n times. So taking the product of these two is like multiplying x by itself m plus n times. So x will go into x cubed, x squared times. The reason for that, x times x squared is
x times x is equals to x squared.
So x times x cubed gives you x squared. And of course,
Is
x,
excuse me, does it give you x squared or cube?
no, it gives me x squared, x cubed.
Yeah, but you just
There's
said
a silent
squared.
one here, so 1 plus 2 is 3. And then when you subtract x cubed is 0, x squared minus 0 is x squared, and then x divides x squared, x times, so I get x squared, and subtract 0, so the remainder is 0. That means your polynomial divides, so the polynomial q divides the polynomial p without remainder. And at this stage, I must put it to you that you will find some polynomials that divide with a remainder, a non-zero remainder. And let me give you an example. So of course, here the answer is x squared plus x. It's px divided by qx, x squared plus x. And you can check if you're right. The way to check this is to take this term and multiply by x. See if you get your original polynomial. This might not always work. You will have some polynomials that divide with a non-zero remainder. For example, if you take ax as 2x to the 4 plus 4x plus 6, bx will be, let's say x squared. Maybe let's use x squared. Of course, the criteria is satisfied. The highest term here is 2, the highest term here is 4, so 2 is less than 4. We can divide. So we want to compute ax divided by bx. So simply 2x to the 4 plus 4x plus 6 divided by x squared. And suppose you want to do your long division, so you have x squared, there's 2x to the 4 plus 4x plus 6. How many times does x squared divide x to the 4? Of course, this will be 2x squared. So this gives you 2x to the 4. Subtract, you get 4x plus 6. And x squared divide 4x plus 6? That's not possible because our criteria was that the term that is dividing must have a smaller degree, must give a smaller degree. But in this case, we want to divide a linear polynomial by a quadratic polynomial, and that's not possible. So in this case, your answer will be 2x squared plus 4 plus x divided by x squared. Because we're having a non-zero remainder. Questions?
So when you are doing the division, like the x square outside the square symbol, it will be constant, Sama.
What do you mean by it will be constant?
The x square outside the symbol of square root.
This one or this one?
Yeah, that one.
What do you mean by constant?
Like when I'm doing the other ones, I will always put x square before doing the upper one.
I don't understand what you are saying. We want to see
the x, yeah, that x square.
How many times is x squared? And we say this is 2x squared. Then when you subtract 4x plus 6. But I've said you cannot divide a polynomial of lower degree by a polynomial of higher degree. This is 4x plus 6 is a linear polynomial, degree 1. You are dividing by x squared, degree 2. That's not possible. So that's why the answer is this. This is called, for those of you who will do.
So what's the symbol of that hapo chini? What's the symbol of 4x plus 6 over at the answer?
What's the symbol
Yeah.
for?
Like
X
what?
squared.
That's wait. So it with the answer is 2x squared plus 4x plus 6 divided by x. So that is that a squared or what's that?
This is a square. This
That
is
is square.
This is x.
Oh, I wasn't seeing clearly. Thank you.
We cannot divide this because the divisor has a higher degree than what is being than the dividend. Is that okay?
What if?
Excuse me, sir. What if the divisor has more than one term?
If the divisor has more than one term, yes. Let me give you an example where the divisor has more than one term. I see we have 3 minutes. I hope that will be enough. When the divisor has more than one term. So for instance, take px, x squared minus 1, and take qx, x minus 1. So the divisor in this case has more than one term. We can divide because this is degree 1, this is degree 2. So we have x squared minus 1 by dividing by x minus 1. Okay? So can x minus 1 go into x squared minus 1? Of course, x can go into x squared x times. Okay? So x times x is x squared, x times minus 1 is minus x. Then you subtract x squared minus x squared, that is 0, minus 1 minus x, this is x. Okay? The x is positive because negative minus negative is positive. And then can x minus 1 go into x minus 1? Yes, it goes there once, and you get x minus 1, the remainder is 0. So you found that x squared minus 1 divided by x minus 1 is x plus 1. So it is possible that the divisor has more than one term.
Please repeat.
I have a question.
Yes.
Now that we're using long division, if I were to say the x squared minus 1 divided by x minus 1, if I was to expand the x squared minus 1, would I still be using the same long division, or do I have to stick to the long division method?
How would you expand x squared minus 1?
X squared minus 1. Okay, let's say x squared minus 1 is equals to x plus 1 and x minus 1 multiplied, sorry, x squared minus 1 is equals to x plus 1 times x minus 1.
Yes, this is true. And this is called factorization. This is not expansion. This is called
sorry.
Which we will do plus.
Oh, so that's allowed. If I used that method to, let's say if the question was referring for me to use the long division and I used this method to divide it, so that will be wrong.
In that case, it will be wrong. If I ask you to use long division, then in that case, you will be wrong. In mathematics, we are not just interested in the answer. How do you arrive at the answer? That's the most important.
Okay, thank you.
Okay, so I hope.
Excuse me, sir, I have a question. So can you do another example?
I think Abdi Hakim, you will remain behind. I give you another example. We have come to the end of the class and I have not marked the register. Is that okay with you?
Yes, sir.
Just remain behind. I'll give you an example.